Hey everybody, Mr. Dixon here. This is the first lesson for Unit 7, Polynomials. Did not obviously expect to be teaching it this way. Um, I'd much rather be in front of the classroom, but we deal with what we have. Anyway, as we're doing this, meaning that you're taking notes and following through in the lesson, make sure you're not distracted. Make sure that you're not listening to music or watching TV, and that you're paying attention to what we're doing in terms of the work. Now, one advantage you have that you don't have in class is that you can pause me, you can fast forward me. Maybe you can't fast forward me now. Let's back it up. But anyway, so you can pause me, and then if something's going on, then go back to the lesson. I'm totally cool with that because there's a lot going on. And this lesson, and maybe the next couple, this is not an easy unit. They're going to be a little long. So I totally understand the pause and then go back. Please use this as a reference. If you're doing your homework and you don't understand something, please go back to the video if you need to, see what we did together. And then if you still don't get it, please send me email. You guys are pretty good at those. I will answer them as quick as possible, especially with everything going on, but I am available for you. All right, let's get into the lesson. Enough of that stuff. Okay, so polynomials, operations, and factoring. That's what we're going through. Like I said, not an easy unit. I know you've heard me say that before. Well, sometimes. But anyway, let's go to our first sheet that we have and that you should have in our OneNote, and that's the reference sheet. Now, these divisibility rules, I know you've done them earlier in your math careers, second, third, fourth, fifth grade, but they are important in terms of what we are going to be doing going forward. So I just want to make sure that you have them and that you use them. Now, remember, when we're talking about a number being divisible by another, that means that it's divided into it equally. So if I have a number, here we go. If I have a number 246, and I want to know if 2 is divisible by it. Well, it says the rule is, and I think you remember this, is that if the last digit is 0, 2, 4, 6, or 8, then that number is divisible by 2. All right, so it ends in a 6, so we know that's a yes. If the sum of the digits is divisible by 3, that means if I add up 2 plus 4 plus 6, is that number divisible by 3? So if I add up 2 plus 4, that's 6, plus 6 is 12, 12 is divisible by 3, so that would be a yes. If the last two digits is divisible by 4, well, the last two digits is 4 and 6, so R is 46. The question is 46 divisible by 4, and the answer is no. If the last digit is 0 or 5, well, we know that obviously the last digit is 6, so that's a no. And divisible by 5 is pretty, I remember back in the day, that's pretty straightforward. If the last digit is 0, it's divisible by 5. The last digit is 5, it's divisible by 5. All right, so if the number is divisible by 2 and 3 is for 6, well, that is true. So the answer is yes. Number 7, cross off last digit to both. Okay, too much. I put a D and D. Do not do. All right? Because all you have to do for all of these actually is take your calculator and the number and divide it and see if it divides equally. That's just a little shortcut. We all have our calculators. Some of these you should know, and it's really helpful, but you can do that. All right, number 8. I know some of you are saying, well, why didn't you say that in the first place? Because these are important. It's mental math, and it's very, very important. All right, this is so weird. I'm talking to someone, and it is you, but you're not in front of me. But anyway, 8. If the last three digits is divisible by 8, well, that's a no. 9. If the sum of the digits is divisible by 9, well, we've already gone through that. We said it's 12. That's not divisible by 9. All right. If the last digit is 0 for 10, another one I've always liked. I mean, that's just as straightforward as it gets. 10, 20, 30, 100, all end in 0, all divisible by 10. So that's a no. All right, so our weird pop-ups are going to happen. Well, they happen in class, and they're going to happen here. All right, number 11, subtract the last digit from the number formed by the remaining digits if the number is divisible by 11. Use your calculator, but this is a no. In number 12, if the number is divisible by 3 and 4. Well, it's not divisible by 3 and 4. I like that one. You should, keep that in the back of your mind. So that's a no for our number 246. All right, so those are good to know, and you should remember those. Let's talk about perfect squares. Another very important concept that we're gonna look at in this unit. We're gonna talk about the difference of perfect squares, the difference of squares, and we really have this one we have to know. And you should. This again is from your past. So the first perfect square is going to be, I hear you thinking, 1. That is correct. Why? Because if I multiply 1 to itself, it equals 1. 1 squared equals 1. That's a square. All right, now, the next one, people, if I were in class, I'm so missing asking this question. People will always say 2. And it's not true because there are no numbers that I can multiply. Well, there is a number, not evenly, that I can multiply together, meaning it's the same, that's going to equal 2. So the next one, and I know most of you are saying 4, because 2 squared equals 4. And then the next one, we'll just go through. Now, what you should do right now is pause the video and then start filling in all the boxes, because you don't need me to talk the whole time while you're doing this work. So why don't you pause and then fill in. Pause. Pause it. Pause. I'll be quiet. All right. Now you're back. So let's fill in. So I have 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. Oops, that's a 5. 256, 289, 324. Now we're getting a little crazy here. 361, but that's okay. 400, 441. Can anyone tell me that one? Huh? And then 484. So we have 2 squared, we have 4 squared. Good game. 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11, and obviously you're catching the pattern. Math. 13 squared, 14 squared, 15 squared, 16 squared, 17 squared. Now, I would say it is so good to know up to 17 squared. I think that's very important. Just have them memorized. 18 squared, 19 squared, and then obviously you should know 20 squared. 21 squared gets a little out of control, and then 22 squared. All right, cool. Again, those are very important, and you should really know those. All right, very good reference, but these perfect squares you really should have down. All right, let's jump into the lesson. All right, kind of back. I had to take a break. Anyway, so here we go. So lesson 7.01, introduction to polynomials. So you should be on this page. I know the notes are there, but I think it's better if you take the notes while we're talking through this, because I just, I'm going to stop, pause, let you do some work, and then you can check your work rather than just writing down the work. I think it's a lot better. Anyway, what are polynomials? Well, polynomials are expressions. We know what expressions are. All right, consisting of one or more terms connected by addition or subtraction. Okay, so polynomials are expressions. We know those are terms without the equal sign. All right, consisting of one or more terms connected by addition or subtraction. All right, so, and we'll talk about some different polynomials in a second, but let's write down that definition. So polynomials, if the pen lets me write it down. Expressions consisting of one or more terms connected by addition or subtraction. All right, and in a polynomial, something very important is the exponent must be a positive integer. All right, must be a positive integer. All right, so that's important. Um, so some examples, just it's not here to have examples, but I think it's important. Let's go green. Examples. 3x is a polynomial, okay, and it's a certain type. We'll talk about that in a second. But the integer there, okay, and we'll talk about that in a second, is positive. So it is a polynomial. 3x squared plus x. We know those are not like terms. We can combine them. We'll talk about that in a couple minutes, but that's a polynomial. Okay, those are two terms. 3x squared is a term, and x is a term. So that is a polynomial. All right, so let's look at exercise 1. It says, of the expressions shown below, circle all of them that represents polynomials. Explain why the ones that aren't polynomials fail the definition above. Okay, so I'm just going to write yes or no, so I'm going to change that up a little bit. So I'm going to go yes or no, and then I'm going to circle what the problem is when it is not a polynomial. Actually, I'm going to do the first one, then you're going to do the rest, and then you're going to pause and check your answer. That's working together. That's what we do in the classroom, and I think we should do that now. So the first example is 4x squared plus 8x plus 1. All right, so is that a polynomial? Well, my answer is yes. Why is it a polynomial? Well, the exponents are positive. It's separated by addition or subtraction. So yes, it meets the criteria. All right, actually, I'll do the second one because the second one's a little tricky. All right, the second one is 9x squared, and it looks a little fuzzy. Sorry about that. That's 9x squared plus 2x, and then that's a plus sign. Plus 1 over x. So the question is that a polynomial? And, well, we have to remember that this 1 over x, and we just learned this when we did exponents, that this 1 over x really is x to the negative 1. I can see some of you going, oh, yeah, that's right. That is correct. So this is a no. It is not a polynomial. And the reason it's not a polynomial is because x now, that exponent, all right, that base is raised to the negative 1. That's not a positive integer. All right, the exponent has to be a positive integer. Pause the video, do the next two. All right, so now that you're back, let's take a look at the next one. That's 2 to the x plus 3 to the x plus 4 to the x. Okay, so that's a no. Why? Because the exponent now is a variable, and the exponent needs to be a positive integer. All right, So that's the problem there. All right, and then let's go to the last one. It says 2x to the second plus 5x to the third minus x plus 8. I know your printout is better than what's on my screen here, and that answer is yes. All right, so let's look at standard form. Standard form, couple things. One, you're going to see this a lot. Ax squared plus bx plus c. Those are all different terms separated by addition. It is a polynomial. A is a coefficient of x squared. B is a coefficient of x. All right, x is a variable. We know that. Two is the degree. All right, that's very important. And C is a constant. It doesn't change. All right, C is a constant. All right, so if I have plus 1, plus 7, plus 3, all right, or plus 8, that's never going to change, but we know variables can change. All right, so something that's important is that it's not stressed as much as it used to be, but your polynomials should be written from the highest degree to the lowest. So it should be written from the highest degree to the lowest. Remember, this is the degree. From the highest degree to the lowest. All right, so an example of that would be, green for the example, 6x squared, oh no, 6x to the 6th, I like this one, 5x to the 5th, 4x to the 4th, 3x to the 3rd, plus 2x squared, plus x. All right, so I'm going from my 6 to 6 to 5 to 4 to 3 to 2. All right, in those degrees. Another example that you have to be careful of is if I have 2x squared y to the 4th plus 5x y to the 5th plus 6x to the 5th. First of all, please, you can't combine those. We'll talk about that later. These are all different terms, okay, because they're variables raised to a certain power. Now, why do I have 2x squared y to the 4th before the other two? Because if I add these two together, that is 6. Let's make this 4. I just got myself in a little bit of trouble here. Let's make this 4. Or let's change up a little bit. So let's make this 2x squared y to the 4th. So that's going to be 6. Let's make this y to the 3rd. Oops, it's supposed to be in green. And x to the 2nd. All right, cool. So I'm adding up these two. So I have, that's going to be raised to the 6th power, that term. This is going to be to the 4th power, that term. And this is going to be to the 2nd power. Now, some of you are saying, how do you get that? Well, I added the 2 powers. All right, so 4 plus 2, 6. 3 plus 1, 4. And then that's to the 2nd power. I add those two together. All right, now, exercise 2. We're going to work on these together. It says, write each of the following polynomials in standard form. So, if I have 3x squared plus 5x to the 3rd plus 7 minus 8x, well, again, I'm writing them from highest degree to the lowest. So I'm going to have 5x to the third. Oops. Let's go to answer pen. 5x to the third plus 3x squared minus 8x plus 7. All right. Why don't you do the next two? Pause, and then we'll come back and check. So go ahead and pause. Pause it. Cool. So for B, I get 9x to the fourth minus x squared plus 2x plus 1. And then for C, negative 5x squared. That's important. You can't get rid of that or change it. Not right there. Minus 2x plus 3. All right, that's a positive. All right, last thing that I want to do with you before you pause, maybe take a break. This is 20 minutes. This is really long. All right, I apologize, but like I said, take a break, go through, take your time with this. I'm going to give you 2 days to do this lesson, and then I have another lesson I'm going to post for you. So we'll do 3 lessons this week. But as you can see, this one is really long, and I'm going to give you 2 days to do it because there's a lot of material in here. Also, much of it should be a review, but anyway, let's take our time and go through it. You can ask questions because as we go further down the road with this unit, it gets definitely a lot more complicated, and you've heard me say that many, many times. All right, anyway, so it says identify each expression as a monomial, a binomial, or a trinomial. All right, so monomial has one term, 7, 3x. Oh, why don't I give an example pen? 7, comma, 3x, 5x squared. All right, if those are all by themselves, okay, those are monomials. Binomial has 2 terms. Bicycle has 2 tires. Okay, so that would be an example. 3x plus 5. All right, those are 2 terms. That's a binomial. And then the last one is a trinomial, and we're going to see that quite a bit. That is 3 terms. Okay, so now that I've highlighted, you can't see it. But anyway, so 3 terms. So you could have, let's see, we've already seen one. So let's go x squared plus x plus 1. Like that. All right, so that is 3 terms. All right, so what you have to do, and you can do this without me, I'll check. You have to identify A, B, C. Wow, that is weird. A, B, C, D, C. I don't know how that happened. But anyway, you have to identify those. Is that supposed to be an E? Yes, it is. Sorry, that's supposed to be an E. Mine is so bad. Anyway, so identify those as binomials, trinomials, or monomials. And pause, and then we'll come back and check. So go ahead. And you're back. All right, so the first one, I have my addition that's separating those 2 terms. So that is going to be a binomial. The second one, B, all right, that has addition that's separating the terms, and then subtraction separating the terms. So that is going to be a trinomial. All right, C, 17x, no addition, no subtraction. That is going to be a monomial. All these meals are making me hungry. All right, D. All right, anyway, D, 3a squared b to the 5th power. All right, no addition, no subtraction. That is going to be a monomial. And then 7, sitting all by itself, a constant all alone. Okay, that is a term, and that is a monomial. All right, now, if I were you, 24 minutes in this, you can see up top, I would take a little break. All right, and then come back because we're going to do our last piece, which is very important. So if you want to take a little break and then continue, or if you want to continue, you want to go forward, go for it. But it's a good opportunity to take a break. All right, we're back. I took a little break. All right, so what we're going to do for exercise 4, we're going to find the sum or difference for each one of these polynomials. Now, I'm going to be honest with you. This is kind of the same thing as combining like terms. So I'm going to put that up here, and I think you should too. All right, so kind of the same as combining like terms. Now, remember, when you combine like terms, you only can add or subtract terms that are the same. Okay, meaning that the variable is raised to the same power. 3x and 3x squared cannot be combined because the x's are raised to different powers. Those are two different terms. That's very, very important. Now, some ways of doing this. So for a, you may have different, I know you've done this before, you may have different ways. If you choose to do it a different way, that is fine with me. I am not going to argue and make you combine like terms or add or subtract these polynomials, because that's what we're doing, in a particular way. As long as we get to the same place, that's what's important. All right, so for A, I'm going to show you one way. I'm going to line it up. I'm going to line up the like terms, and then I'm going to add. Whatever you like, whatever you choose is up to you. All right, so what I do is write down the first trinomial. So I have 4x squared plus x plus 7. Okay, I like to write them down in standard form or in descending order, because that way my answer will be in the same way. All right, so underneath, I'm going to line up the like term. So the like term for 4x squared is, yep, 2x squared. Very good. And then the like term for x is 3x. Very good. And then my constant. So I'm going to have plus 1. All right, I'm going to draw a line and then the plus sign because I'm adding. All right, so when I add down, I'm going to have 6x squared, all right, plus 4x plus 8. Please, a couple of things. One, do not add the exponents. We are adding like terms, okay? You add the exponents when you are multiplying, and we'll see that in letter C. Anyway, so let's go to letter B. And also, your answer should be in descending order. That's important. All right, so I'm going to do the same thing here. So I'm going to write down my first trinomial. So I have 5 minus t minus t squared. All right, so I left a little space because now I'm going to put my like terms underneath. So I'm going to have plus 9t. Yes, that's a 9. And then I'm going to have plus t squared. All right, pretty cool what happens here. Plus sign, my 5 comes down. That's like a 0. It is a 0. And then I have negative t plus 9t. Well, that's going to be plus 8t. And then I have negative t squared plus t squared. Well, they cancel. So my answer is 5 plus 8t. All right, cool. Now, what I'm going to do is show you another way of doing this. All right. So you don't have to line them up. You can just go, you can add the numbers or the terms that are next to each other or not next to each other, but you don't have to line them up. Anyway, let's go purple. Let's get a little change here. All right, so I have 3a, and that's times. That is times the quantity 4a squared plus 3a plus 1 plus 7 times the quantity a minus 5. I've been saying that all year on purpose, just that way, because the first thing you have to do here is, yep, you have to distribute. So I'm going to distribute the a I'm sorry, the 3a, and then I'm going to distribute the 7. So when I do that, all right, now we're multiplying, so we add the exponents. So I'm going to get 12a cubed plus 9a squared plus 3a. Okay, that's going to be plus 7a minus 35. All right, now, besides lining them up, as I said to you, I'm just going to add or combine the terms that are next to each other or just not lined up. All right, so I'm going to drop down 12a cubed, all right, because I have nothing to combine that with or add that with. I have 9a squared. I have nothing to add that with. A little trick sometimes is to cross off the ones that are combined. That way you know you've gotten everything. All right, so I have 3a plus 7a. We know that is 10a. Cross that off, and then minus 35. And that's your answer. Okay, now, no, I don't want you to do, let's do E first. So let's go down to E. And this is the reason that I want you to listen to the videos and go through this together, because I think it's a help, and then we're working together, and that's what we do in class, and we're trying to mimic, I know, through these times as much as we can in terms of the classroom experience. All right, so here we go. So we have 3a to the third minus x squared plus 8 minus x to the third plus 5x squared plus 4x minus 7. Now, something very important. Remember when we have negative 4 minus 3. If we have that, okay, when we have integers, and that's what we have here, we don't subtract the integers, we add the opposites. So that would become negative 4 plus negative 3. Okay, we add the opposite. Keep, change. I don't know, however you learned it. Why is that important? Well, that's important because, oh, go back purple. This minus here, which is really minus 1, we have to think about, gets distributed to every term in the parentheses. Very, very important. That negative 1 gets distributed to every term inside the parentheses. I'm going to erase that just so that we can see. All right, so I'm going to have 3x cubed minus x squared plus 8. And now I have minus x cubed minus 5x squared minus 4x plus 7. All right, that's really important, okay? Because if you don't do that, if you don't distribute that negative 1 to every term inside those parentheses, we're going to get totally different answers. Okay, so now I have to look and say, okay, I have 3x to the third. Do I have any other x to the third? Yes, I do. All right, so I have 3x to the third minus x to the third. That's going to be 2x to the third. So I'm going to cross those off. I'm going to look for my squares. I have negative x squared, and I have, that's going to be minus 5x squared. Negative x squared. Now, if you need to do this, negative x squared minus 5x squared. What does that equal? Well, that's a 1 there. That's important. All right, plus, minus. All right, so that's going to be negative 6x squared. Very important. All right, so let's cross off my squares. I have nothing with x raised to the 1 power except negative 4x. And then I have to combine my 8 and 7, and that is 15. And that's my answer. And it's in descending order. Okay, now the reason I did that is because what I want you to do is D, F, and G. I want you to do those on your own. All right, we're coming to the end of the lesson, so I want you to do those on your own. It's a good test, and we'll do those together. So why don't you go ahead and pause the video and go through those. All right, good job. I hope you paused. Anyway, so because it's better for you to work than just to see me work. So for D, for 2x, I distribute it. That's the first thing you have to do. All right, told you one of the most important properties in math. So I'm gonna do a little separating here to make sure. All right, so I get 2x to the third plus 6x squared plus 2x. All right, and then going across, I get plus 4x squared. And then that's going to be minus 6x plus 12. All right, now people will say it's really the same concept. If you distribute it 1 there, I mean, 1 times any number is the number. So it's really that same concept of distributing that -1. So anyway, so I get 2x to the third. Do I have any x to the thirds? No, I don't. So I'm going to bring that down. All right, I'm looking for my squares. So I have, ooh, did you catch that? Did anyone catch that? This is 6x squared. Okay, good catch. All right, I know some people caught that and they're going, all right, good job. Anyway, so 6x squared plus 4x squared is 10x squared. I like that you caught that. All right, and then I get, see, so that's looking for my x's raised to the 1 power. So I have 2x minus 6x. That's going to be minus 4x. Good. And then that's going to be plus 12. Good job and good catch. I miss you guys catching me on the mistakes I make every once in a while. Anyway, so here we go. Let's go F. Why not? So F, this is going to be distributing that -1. So I'm going to first bring down 3x to the third plus 8x. Now I'm distributing the -1. So that's going to be negative x to the third negative x squared -12. Okay, now you may think that doesn't matter, but if it matters is as you move through math and as these variables represent real world issues or problems, I mean, it matters quite a bit. Anyway, so let's go 3x to the third minus x to the third. That's going to be 2x to the third. Let's go x squared minus x squared, nothing. Let's go plus 8x by itself. Let's bring that down. And then let's go minus 12, that constant, it comes down also. All right, good. We are almost there. Oh, it's almost like class time. Anyway, so last one, we have to do a little more distributing, but we're going to work through it. That is a plus sign. It looks bad on mine. I'm sure it looks good on yours. So I have 3p. I'm going to start over here, plus 1. And then I have plus, because I have to distribute that 6, plus 6p. And then that's going to be minus 48. Then I have to distribute the -3 to both terms inside. So that's going to be minus 3p minus 6. Cool. All right. So now my p's, I have 3p. I have 3p, -3p. They cancel. Then I have 6p popping out. I can get rid of that. I have 1, -48 minus 6. I add that up. Minus 53. And that's my answer. All right. We have made it through the first lesson, 39, 40 minutes. As you can see, my counter up top, a little long. I apologize. Now, as you're going through this, break it up. Hey, we're on unusual times here. Your homework with this, okay, look in the packet. All right, the homework it's in the second half of the red packet. So it's pages 20 and 21. I am pretty sure you got the answer key with this. Okay. So work through those problems. If you have any questions, let me know. What I will do, I will post another video late tomorrow because I really want you to concentrate on this so we can go forward. Any questions, please email me. I have no problem with that. I apologize because what might happen, there might be sounds as this loads up to YouTube. There might be sounds as I'm writing. I know that happens. Apologize for that. A little squeaky. I don't like it, but that's something I can work on at some later date and time. I hope everybody is well. I hope you're in good spirits according to what's going on. I know. And I hope everybody's well. I do miss everybody. I'm not just saying that. And we will talk next time. All right. Have a good night.